Okay, and welcome to the next section in 2-1, the Pythagorean Theorem. Now, what is the Pythagorean Theorem? It allows us to solve for the missing sides of right triangles, and that is so key for you to know. Alright, we can only find the missing sides of right triangles using the Pythagorean Theorem. So let's take a look at example 1. It's asking us to find x. Now you might remember something special about this word x. It is clearly the longest side of the triangle. And so remember, when you have the longest side of the triangle, we always call that the hypotenuse. Okay? Hypotenuse. Okay. Now from here, this side is going to be referred to as a leg, and this side will be referred to as a leg. So we have the hypotenuse and the legs of a triangle. And one other trick that I always want you to get in the habit of is always draw an arrow through the right angle box, because if you draw an arrow through the right angle box, it will always point to the hypotenuse. Take a look at example 2. I draw my arrow through the right angle box. It is pointing to the hypotenuse. Okay, now from here, let's go ahead and talk through the Pythagorean Theorem. The Pythagorean Theorem is this formula: a squared plus b squared is equal to c squared, where our hypotenuse is the letter c. So let's just plug in everything. Oh, and let's even just label these right here. A and b are going to be the legs. And which one you choose for a, which one you choose for b really doesn't ever matter. So we could say this. We could say that 6 squared plus 8 squared is equal to x squared, where I chose my leg 1, my leg 2, and my hypotenuse, a, b, c, and I plug them in. Now from here, we know that a square means to multiply by itself. So for instance, 6 squared is 6 times 6, which is 36, plus, I don't know why I wrote an x, plus 8 squared, here, just so you're not confused at home, silly man, plus 8 squared, 8 times 8 would be 64, is equal to x squared. Now from here you would ask yourself, well, what is 36 plus 64? And if you need a calculator, that's okay. That would be 100 is equal to x squared. Now here's one of the number one things that geometry students kill it on, like absolutely crush it on, and Algebra 2 students for some reason struggle. So here's a new tool for your toolbox. When getting rid of a square, you get rid of a square by taking the square root. And what we do to the right, we do to the left. Alright, so we're taking the square root of both sides. Now what is the square root of 100? What is the square root of 100? Well, I've included my entire screen for this video because see here up at the top we have Desmos Scientific, and you can go down here in the bottom left and you actually see the square root symbol. So I type that, and then I type in 100 and look all the way over to the right. You'll see my final answer is 10. And if you push that blue button, it will record your answer. So let's go back to this. So we know that 10 is equal to x, or we would say x is equal to 10. Remember, the order with which you write an equal sign doesn't necessarily matter. And we could even label this side up here as 10. Okay, let's try and go through example 2 a little bit quicker. Example 2, we use our Pythagorean theorem, a squared plus b squared is equal to c squared, where I know that one leg is 12, so I could write 12 squared plus my other leg is x squared is equal to 15, our hypotenuse squared. And what if 12 squared, y'all know 12 squared. 12 squared, 12 times 12 is 144, plus x squared is equal to, but most of y'all won't know what 15 squared is. So I go back over to Desmos Scientific. In this case, I type the number first, 15, and you'll notice, see where it says a squared? I push that, and now I have 15 squared, which is 225. Okay, so this is equal to 225. Well, I subtract my 144 minus 144. We're just solving for x. We want to get it by itself. And we now have this. We have x squared is equal to 225 minus 144. Let's see. 25 minus 144. And that will give us 81. Oh, this is actually working out really nice. And y'all tell me, how do you get this? How do you get rid of a square? Well, we take the square root of both sides. So the square is that funny little check mark box, and of course the square root and a square cancel, and we're left over with x equals, and most of y'all know this, but the square root of 81 would give us, look over here to the right, 9. Okay, so x equals 9. That is a lot. I would encourage you to pause this, finish taking the notes. I'm going to do one more example for anyone who doesn't quite get this. Here's our example 3, and let's do something kind of funky. I mean, I think it's funky. But let's just say that this is going to be 9, and let's say that this is going to be 2, and I want you to find x. How would we possibly set this up? Oh, and by the way, I have to give you that it's a right angle. Remember, if it's not a right angle, it does not work. So, through our right angle box, we can draw our arrow, which points to the hypotenuse, which I'll just abbreviate like this, hypot. And we know that that is our letter C. And once I know that, this becomes so easy. I type in a squared plus b squared is equal to c squared. And from here, I know I could choose either one of these to be a. It doesn't matter. Let's do x this time. So x squared plus, oh, I'm sorry, I meant to underline 2. I could choose x or 2 as my a term. But since I chose x as my a term, I'll choose 2 as my b term. And then, of course, 9 is our c term, so 9 squared. Now from here, we know x squared can't really change, but what is 2 squared? What is 2 times 2? And that'll be 4. And here we know 9 squared from our previous problem is 81. Now how are we going to get x squared by itself? Well, we just do simple algebra. We get rid of our addition by using subtraction. Now I have x squared is equal to 81 minus 4, or aka 77. And how do I get rid of that square? Well, I take the square root. Remember, square and square root, they're opposites. And here, you're going to get a trickier answer. If I type in the square root of 77, I will get 8.77 and then a bunch of other decimals. Let's just round it to 8.77. Alright, I'm going to do one quick final example. Here's example 4. And let's say 3 and 3, and I'm asking you for x. Can we solve for x in this problem? Think about it. Can we solve for x? And the answer is no, because it's not a right triangle. So in this case, we cannot solve for x using the Pythagorean theorem. Alright, I hope this helps. Good luck, and I'll see y'all in our next section.